Here's a relatively straightforward thermodynamics question. So it's quite simple. We have to find out the density of a certain gas mixture. Okay, and this is something that you might do if you are a high school student preparing for some kind of competition, perhaps, or most likely you'll see this in your first year of undergraduate engineering if you're doing something like civil engineering or mechanical or aerospace engineering. So if you'd like to see anything similar to this on the channel, please let me know in the comments. So let's read the question. We've got a vessel which contains a mixture of nitrogen. So nitrogen is the gas that has the chemical symbol N2. So it's, this is the molecule of nitrogen. And then we have carbon dioxide, which is just CO2. We know the masses of both. So we know that in the vessel we have 7 grams of um, nitrogen and 11 grams of carbon dioxide. We know the temperature, which is 290 Kelvin, and we know the pressure as well as being just standard atmospheric conditions, just 1 atmosphere. And we have to find the density of the mixture, okay? Now, what you shouldn't do is say that the average density, so rho with a bar on top, is density of the CO2 or density of the nitrogen plus density of the CO2 over 2. Okay, this is not what average density is. This is not how average density is defined. Average density is simply the total mass of the gas divided by the total volume of the gas. Okay, this is the true definition, the true textbook definition of average density. So the total mass of the gas, that's the mass of gas 1 plus the mass of gas 2. So let's say that gas 1 is the nitrogen and gas 2 is the CO2, divided by the volumes of the two gases added together. So we have V1 plus V2, right? Because they're both in the same container, but you can kind of think of it this way. So you can say that CO2 occupies some, part of the vessel and nitrogen occupies the other part. In reality, it's not going to be like this. The molecules are going to be mixed together, but CO2 takes up a volume V1 and or nitrogen takes up a volume V1 and CO2 takes up a volume V2. Now we know what M1 and M2 are. The question tells us what they are, but we don't know anything about V1 or V2. So let's write the ideal gas law. So we have that for the first gas, for the nitrogen, we have the pressure P0 times the volume is equal to M1, and then we have R, this is the universal gas constant, divided by the molar mass, and I've written the molar masses here, right? So this is M1 and this is M2. You can take this from the periodic table. So this is 28 kilograms per kilomole for nitrogen and 44 kilograms per kilomole of carbon dioxide. So this is multiplied by temperature T, and for the second gas, for the CO2, we have P0V2 is M2 universal gas constant over M2 times T. So from here we can actually find out what V1 is. So V1 is M1 RUT over P naught V1. So just P naught M1, I meant. So that's it. And then from here we can get that V2 is equal to M2 RU times T over the same pressure times M2. So one important thing to note is that the pressures of the nitrogen and the carbon dioxide, they're the same. Okay? So they're part of the same container. So no matter where you measure the pressure, whether it's here or here or here or here, you'll get the same pressure throughout. So the two gases have the same pressure, P0, which is 1 atmosphere. So what I'll do then is I will take those and I'll just substitute them in here. So instead of V1, I'm going to write the stuff in yellow. Instead of V2, I'm going to write the stuff in green. So the average density is therefore M1 plus M2, that's the total mass, remember, divided by the total volume, and the total volume is M1 RUT over P naught V1 M1 plus M2 RUT over P naught M2. So let's maybe simplify this as much as we can. I can bring the P naught on top, so this is going to be P naught M1 plus M2 over. And then we have universal gas constant multiplied by T multiplied by, and then we have M1 over capital M1 plus M2 over capital M2. Okay, and in this expression that we have here, we actually know everything. So we know the pressures, we know the temperature, we know the masses, we know everything else basically. So let's try to get a value for density by putting the numbers in. So this equals P0, which is 1 atmosphere, which is 10 to the power 5 pascals, times, so M1 plus M2, it's 18 grams, but 18 is 18 times 10 to the minus 3, because we're working with kilograms. Then the universal gas constant is 8310, and then we have a temperature of 290 Kelvin, so let's put 290 Kelvin here, times, and then in this bracket we have M1, which is 7, but that's 7 times 10 to the minus 3, over M1, capital M1, that's the molar mass of nitrogen, so that is 28, like this. And then we have plus M2, that is 11 times 10 to the minus 3 over 44, like that. Okay, so what you'll notice is that the 10 to the 3's cancel out, which is nice. Now this here is 1 over 4. This is also 1 over 4. So the bracket is 1 over 2. And if we put everything together here, we'll have that average density is 18 times 10 to the power 5 over, and then we've got 8310 times 290 times 0.5, 1/2. Okay, so let's see how much we get if we solve this fraction. So we have times 10 to the 5. Okay, so this is about, I get something like 1.493 kilograms per meter cubed. Or you can approximate this if you want to 1.5 kg per meter cubed. Okay, so that's how you do this kind of question. You write the average density as the total mass over the total volume, and you will end up with this. And that's the end of the question.